My name is George Butler, and today I'm going to be talking about the enzyme that I engineered called sebamase. What is the function of sebamase? Sebamase is meant to break down the excess sebum oil that resides within the sebaceous glands of human skin by targeting the production of triglycerides in wax esters with pancreatic lipase enzymes. Sebamase is a pancreatic enzyme that was engineered to be inserted into the pores of human skin. Pancreatic lipases break down triglycerides, which make up more than 60% of the sebum oil that resides in skin pores. This is a diagram of hydrolysis that breaks down the complex triglycerides into mono and diglycerides. This is the structure of the pancreatic lipase. The active site is where the catalytic activity takes place. The goal of sebamase is to make people feel better about their skin without needing to use a multitude of creams and masks. Now I will show a video of how the pancreatic lipase breaks down the triglyceride. This is the triglyceride that has already been broken down into a monoglyceride. As you can see, there's only one fatty acid, but then there's the whole glycerol molecule. So this is what makes up a monoglyceride. So basically, for the purpose of this video, I will be showing how the lipase enzyme cuts the bond between the fatty acid and glycerol so that OH and H can then be added to the two separate molecules. So here is a monoglyceride. It has the glycerol and then the fatty acid. The lipase, which is shown by these scissors, cuts the monoglyceride right at this bond. Okay, so cuts it, right? Then the water can be added as an OH and an H. So the OH is attached to the fatty acid. So now this just becomes a fatty acid. And the H is added to the glycerol molecule. So now there's just two separate molecules. Let's talk a little bit about the engineering process of the enzyme. To engineer sebamase, dipteran insect cells would be used as cell culture hosts that would grow the enzyme when the pancreatic lipase gene was inserted into them. Then, once the cells have grown, using UV light, the cells would be randomly mutated, and a 96 well plate would hold the mutated cells. Once they have been mutated, a robot would screen the cells to check for enzymatic activity. When the robot determines what cell produced the highest amount of enzymatic activity, that would become the sebamase enzyme.